here's the plan for the week. We are obviously on our A block day. We're going to do 11-2, which is surface areas of prisms and cylinders. And then Wednesday, we're going to do surface areas of pyramids and cones. And then Friday, we'll start your review for your last test, which is next week, next Wednesday. That test is going to cover the 10, 6, and 7, which was on your quiz, and then the 2 new sections. It's funny because my son is in 5th grade, and he's doing solids right now. Like, he's not going as in-depth as we go, obviously, but I literally listened to him listen to a video, and I joked that I should play it because it was so bad. It was like a lady who was speaking like she was a kindergarten teacher. Like a pentagon is, and then like all of it was graphics, and I was like, oh, maybe I should let you guys just watch that instead of having to listen to me. But then she called it a pentagon instead of a pentagon, spelled it wrong, calls them vertices instead of vertices. So I was like, nope, I think I'll stick to our teaching. Yeah, but what that told me is hopefully these are shapes you have seen before, starting in elementary school, working your way up. But again, we're going to go a little bit more in depth because we're going to do surface area. So there's 4 different types of solids you're going to eventually learn surface area for. You can use a formula sheet for this. We will do that together on Monday. I would strongly recommend that you, like take whatever extra caffeine you need to before Monday's class so that you're super alert and paying attention, because we'll build a reference sheet in class on Monday that you can use on your test on Wednesday that has all the formulas from the circles and the solids with some examples. So hopefully that will help you with your last test. So this is surface area of prisms and cylinders, 2 of the 4 we're going to do. Some basic vocab, like what is a prism. So a prism is called a polyhedron, which is basically a 3D figure. Okay, so we're leaving the 2-dimensional stuff like the circles and the squares and the rectangles, and we're getting into 3-dimensional figures. There's 2 congruent parallel faces, which are called bases. And then the other faces are called lateral faces. So these are, again, just some vocab terms. You're not going to be tested on the vocabulary, but you got to understand it in order to answer the questions. And you can name a prism using the shapes of its bases. So here's just 3 examples. There are more than these. The first one is a rectangular prism, and this is probably the most common, okay? Every rectangular, like a cereal box, a tissue box, all of those are rectangular prisms. You've got a lot of those in your household, okay? This is not the easiest thing to teach without being physically in front of you, because normally I would hold up an example of what a rectangular prism looks like, but we're going to just look at it here. All the sides of your box are called faces. All the lines that would connect all those sides are called edges. And then all the points where they meet, those little corners, are called vertices. In a rectangular prism, you've got a lot of options for bases. So we can always say maybe the top and the bottom are the bases, no matter which way our rectangular prism is facing. You could also say left and right, front and back, as long as they're parallel, so the 2 sides that don't touch each other ever. Those could be your bases. Only in a rectangular prism are there more than 1 set of bases, so you can kind of pick which one it is. So again, like I would say, maybe always do top and bottom. We'll kind of try to stay consistent with that. And then the other sides are called lateral faces. So if I identify the bases as the top and the bottom here, so if I said these 2 were the bases, then the other 4 sides, the front, the right, the back, and the left, those would be considered lateral faces. But again, it doesn't, for a rectangular prism, you can pick any 2 sides. As long as they're parallel, as long as they don't touch, you can pick any 2 sides as the base. And this would be called a rectangular prism, okay? Something like a cube is actually a rectangular prism. It just has squares as all the sides. Then you've got these 2 examples, which are still prisms, but like if you look at the one in the middle, this top and the bottom are a pentagon, okay? So if there's any other shape on your prism other than a rectangle, that's the base. So in this case, the top and bottom are pentagons. So this is a pentagonal prism. Those top and bottom in this case would be the base, and all the other sides would be the lateral faces. The edges on those faces are called lateral edges. The last one is a triangular prism, because both the top and the bottom are triangles. The other sides are still rectangles, but the top and the bottom are triangles. So those are considered to be your bases, and then the other ones are called the lateral faces. So again, just some vocab here so that we can get into formulas. All right, so extra parts of a prism. A prism has an altitude or a height, which is the perpendicular segment that joins the bases. So if I, for example, had a rectangular prism, and I said the top and the bottom were my bases, then the height could be any of the segments connecting the top to the bottom. So this could be the altitude or the height. This one could be the altitude, the height. That one could be the altitude, the height. That one, all of those could be the altitude, which is also the height. Same thing. If I had a, like, let's say I had a rectangular prism. Sorry, did I say rectangular? A triangular prism. Now the bases would be the front and the back of this prism. The height is going to be here, or here, or here. The perpendicular segment that connects the two bases. The lateral area is the sum of the area of all the lateral faces. So all the sides that are not a base, if I added up the area of all of that, that's the lateral area. And the surface area is the total area. So there's a couple ways to do it. One is find the area of every single side and add them all together. And the other is to use a formula that we're about to get. So I will give you a formula to find the surface area or total area of all four different types of prisms. Solids, or all different types of solids, which are going to be prisms, pyramids, cones, and cylinders. And you can use that formula for your test. So there's 4 different formulas there. And here's the first one. The lateral area, which again is the area of all the lateral faces, so not the bases included, is equal to the perimeter times the height. So the perimeter of the base times the height of your prism. And then the total area is the lateral area plus 2 times B, and B stands for the base area. Or if you didn't find the lateral area first, then you can go straight to total area by 2B plus PH. Alright, so this is what it could look like. It's just gonna, this one just says find the surface area of the prism. So if it had asked for lateral area and surface area, I could do those separately, but because it asked for the surface area, I'm gonna go straight to my total area or surface area equation, which is 2B plus PH. So now this is a rectangular prism. I'm going to say the bases are the top and the bottom. So base 1, base 2. So to find B, I want the area of the base. It doesn't matter if you pick the top or the bottom. The bottom has the measurements on it, so it's probably easier to pick that. That's a rectangle. So it's length times width, or base times height, which is 4 times 2. So the B, your base area, is 8. The P is the perimeter of the base. So we find perimeter by adding up all the sides. So if this is 4, this is 4. If this is 2, this is 2. So the perimeter would be 4 plus 2 plus 4 plus 2 for 12. And then the height is going to be the segment that connects the two bases, which is 6. So then I plug it all in. The total area equals 2 times B, which is 8, plus P, which is 12, times height, which is 6. 2 times 8 is 16. 12 times 6 is 72. Add those two together, and I get 88. This would be area, so it would be centimeters squared. Questions on that one? So that's a rectangular prism. You got to find the area of the base, which is a rectangle. You got to find the perimeter of a base, which is also a rectangle. And then you've got to figure out which of them is the height. And then plug it all in. So again, like before, you'll get to use a calculator. Use that to your advantage. You can multiply those numbers together and add them up. All right, here we go. Find the surface area again of a prism. So I know it's a prism because it has two bases and then the other sides are rectangles. Because I've got different kinds of shapes as sides this time, I know that those are the bases. So I know that on this one, the top and the bottom are the base, which means that this is a triangular prism. Which means I'm going to still use 2B plus PH, but B, the base is a triangle, which means the area of a triangle can be found 1/2 base times height, which is 1/2 the base of that triangle could be 3 and the height could be 4, or 1/2 of 12, which is 6. That's the area of one base. Then I need the perimeter of that same base, which means I need to add up all my sides. I have 2 of the 3 sides. There's a 3 and there's a 4. I'm missing the hypotenuse of that triangle. If you remember your triples, this is where they come in handy. That's a 5. If you don't remember them, then you've got to do the Pythagorean theorem. 3 squared plus 4 squared would equal the hypotenuse squared, or c squared. 9 plus 16 is 25. C would equal the square root of 25, which is 5. So if you don't remember your triples, that's how you have to find them. Or if it's not a triple, because it won't be a triple, that's how you'd find them. And then you add up those 3 sides. So 3 plus 4 plus 5, or 7 plus 5, which is 12. And then the last thing we need is the height of the prism, which is 6, the side that connects the two bases. So now I get total area equals 2 times B, which is 6, plus perimeter, which is 12, times height, which is 6. 12 plus 72, which is 84 centimeters squared. So these tend to be a little bit complicated because there's a lot of parts to them. You got to be really careful and make sure you practice these. There are tons of different types of prisms. Like it could be a hexagonal prism, it could be a pentagonal prism. But I'm just going to keep them, we're going to keep them pretty basic. We're going to keep them to rectangular prisms and triangular prisms. And that way it's easier for you to find the area. I don't want you to have to go back to 1/2 A and S, like all those polygons. I don't want you to have to go back to those formulas. We're going to kind of try to stick it to these. But you could like see a prism that has a trapezoid as its base. You could see a pyramid that has all those different types of shapes we've had in the past. You can see those come back into play. I'm going to, like I said, I'm going to kind of keep it simpler. We're going to keep it to just the rectangular prisms or the triangular prisms, so we know how to do those and we can practice those more. But realize that there are tons of different kinds of prisms out there. Everybody good on those? Okay, so next up is a cylinder. So what happens if the bases are circles of a prism? It becomes a cylinder. So when you take those bases and you make them circles, they become a cylinder. So a cylinder is a solid that has two congruent parallel bases that are circles. The altitude, which is the height, is the perpendicular segment that joins those circles. So in this case, here's my height, and the circles are my bases. The lateral area here is the same thing as perimeter times height, because perimeter of a circle is the circumference, and that's what the 2 pi r is. So 2 pi rh is the lateral area. And the surface area or total area is 2b plus ph, which is 2 pi r squared, because the b is a circle, plus pi rh. Or if you already found the lateral area, you can do 2 pi r squared plus the lateral area. So if it asks you to find lateral area, then total area, I would use the first one. If it says just find total area, I would use the second one. All right, so example 3 says find the surface area of the cylinder. We just said that the formula for surface area is 2 pi r squared plus 2 pi rh. We're going to leave these in terms of pi, which is what the homework says to do too. So really the only things I need to identify from my cylinder are the radius, which is 5, and the height, which is 7. So then the total area or the surface area is 2 times pi times r, which is 5 squared, plus 2 times pi times r, which is 5, times the height, which is 7. So I'm going to do 2 times pi times 25 plus 2 times pi times 5 times 7. And we can rearrange these any way we want. So I'm going to kick the pi to the end of each of these. So I get 2 times 25 times pi plus 2 times 5 times 7 times pi. This becomes 50 pi plus 2 times 5 is 10. 10 times 7 is 70 pi. And then because they both have pi on them, I'm going to add those two together. 50 plus 70 is 120 pi, and it's centimeters squared. Questions on those? All right, last one. Find the surface area of the cylinder. So if you look at this, what's the difference between this one and we were just given? It's still the same shape. So my area is still 2 pi r squared plus 2 pi rh. But hopefully you catch that the difference is we're given the diameter instead of the radius. So you've got one additional step here, which is if the 16 is the diameter, the radius would be 16 divided by 2, which is 8. And then you just plug it in. So 2 pi, radius is 8 squared, plus 2 pi, radius is 8, height is 21. Square the 8, so 2 times pi times 64, plus 2 times pi times 8 times 21. Bump the pi's to the end, so 2 times 64 pi plus 2 times 8 times 21 times pi. 2 times 64 is 128 pi plus 2 times 8 times 21, 336 pi, and then they both have pi, so I'm going to add 128 plus 326, and I get 464 pi. There's no unit this time, so it would just be units squared. Questions on that one? All right, so this is what the homework should look like, right? So it says, for the first one, find the surface area of each prism. These are all prisms, numbers 7 through 12. They're prisms. So you're going to use total area or surface area equals 2b plus ph for numbers 7 through 12. Hang on. Go ahead. It's total area or surface area. So it's a slash. Because sometimes you'll see them say surface area, right? This says surface area. Sometimes standardized tests will say total area. It's the same thing. So just get used to those two are the same thing, okay? So for 7, you've got a rectangular prism. For 8, you've got a cube, which is also just a rectangular prism. For 9, you've got a right triangle prism, so you're going to have to use the Pythagorean theorem to find C, which would give you the perimeter. So you're going to have to use that one. For 11, you're at, again, a rectangular prism. 12, you've got a triangular prism. And again, you've got to find the missing side. This time it's a triple. So when you go to find your perimeter, when you go to find C, it's a triple, so that should save you a little bit of time. And then for 17, 18, and 19, you're using surface area equals 2 pi r squared plus 2 pi r h. So I'm going to give you a little bit of time. You got 15 minutes left in class. Go ahead and start these, so if you've got questions, you can ask. Okay, remember to keep these in terms of pi here. 18 and 19 both give you the diameter. You're going to have to cut it in half. So those you can use your calculators to square them because they're going to be decimals squared. Feel free to use the calculator there. But make sure you keep them in terms of pi.